Hello, welcome to another video of our Engineering Economics 2373, and in this video we're going to talk about very basic functions uh, in Excel associated with this course. So the first thing that we need to remember is these formulas that we have here, how to compute the present value and the future value are expressed by these equations. So let's consider a very simple example in which we're going to have the period, and let's say we have period at t equals 0, t equals 1, 2, 3, 4, and 5. The cash flows that we're going to have are negative 1000. Let me zoom in there a little bit for you. We're going to have cash flows negative 1000. Let's consider that would be our initial investment, and later on we would have, say, positive cash flows of $400. In this situation, this would be the cash flows. And let's say that the interest rate that we want to consider in this example is 10%. So by the fact that we have this formula here to compute a present value, what we need to do is we need to bring each one of these cash flows to the present depending on when they happened. So the first one would be just 1000 negative divided by 1 plus the interest rate, and I'm using an absolute reference so that when I copy that, it will always make reference to the same cell, and that should be raised to the negative 0. Of course, that is just raised to the 0, and it doesn't make any difference. But now I can copy that by double clicking in the very left bottom corner of the cell, and that copies the equation that I have, the formula, and I just click on comma to format, and there you go. You have each one of these cash flows have a different present value because we are discounting the original 400 into by one period 10%. The equivalent today is $363.64. $400 that we would receive 2 periods from today would be equivalent to $330.58 today if the discount rate is 10%, and so on and so forth. So we can compute here the total, and the value of this project is $516.31. So in this way we can compute the present value of all these cash flows put together. This is not the only way that we can do it. We can also compute the present value of these 400 if they are all the same using a formula that reads like this. It's equal present value, just PV, and then it's asking for the rate. The rate is 10%. The number of periods is, as you can see, we have 5 periods of 400, so we have 5. And then the payment is going to be 400. I'm going to use, if I use 400 just like that, since it is expecting that if I make an investment I will receive positive cash flows, and if I receive a loan and then I would have to pay it, it is computing the value in the with the negative sign. So in general what I like to do is I like to use negative sign on the cash flows, and then I know that this is the value that I have just for those $400 that I receive, and then from that I would subtract the cash flow that I have, that I know it's already at t equals 0, that is the $1,000. So if I subtract these $1,000 which are negative, that's why I use the plus sign, the value that I have is exactly the same. So there you go. Those are two ways to compute the present value for equal cash flows. Now, of course, the benefit of doing one by one is that you could have here independent numbers. That it's if I have a situation in which I have an initial investment of a negative 1000, but then these numbers are different, say 300, 400, 500, and then maybe again 400 and then 200. Now the computations remain the same. If I use these formulas, I can do this cash flow divided by 1 plus the interest rate, which it remains the same, raised to the t, and I can obtain the new solution for these cash flows happening on periods 1 through 5. And that would be the benefit of computing one by one, as opposed to having it fixed always the same amount. So you have more flexibility. And as I said before in the course, this is the simplest, most important equation you could have, and I strongly advise you to memorize that one, because you're going to need it time and time again. Okay, very good. So let's see. This was the present value, and we can compare these two. This is the present value, and as you can see, both are for the same amount. Now what we could do is we can compute a future value as well, and the future value would be the future value of, again, the rate is 10%, the number of periods is 5, and the amount that we are depositing is 400. Okay, and now on top of that, now we need to subtract the 1000, but the 1000 is coming from it's a negative value, and it's coming 5 periods before. So I need to bring that 1000 to the future before I subtract it. So what I would do is, this value is already at t equals 5 minus, now I need to compute the future value of rate 10%, number of periods 5, but this is not a payment. PMT stands for payment, and those are the annuities. I'm going to leave that space in blank, and then I'm going to use PV, which is an optional value. That's why it has brackets, and that would be used for the negative 1000. So it's negative 1000. So the future value is 831. Compare that to, if we compute the future value of all of these, would be this cash flow times 1 plus the interest rate raised to the, now I have to count how many periods I have until I get to 5, so it's 5 minus 0, and I copy that for the next few rows, and now I can compute the sum, and sure enough, these two quantities, the present, the future value, is now the same. These being the future value, and these being the future value. Okay, I'm going to make another video to continue this example. So keep practicing. Thank you very much.